Hi, I'm Jennifer.
And I'm Jackie, and we're here to figure out the age-old question, is visual learning actually better than auditory learning? Most people say they always remember what they see, but never what they hear.
So now we're investigating to see if these claims have statistical evidence to back them. To start our investigation to this statistical question, we started at Canyon Crest Academy and took a sample of 31 students.
The 31 students then took 2 memory tests. Quiz 1 had the phrases said aloud, while Quiz 2 had the phrases read. Both got corresponding questions regarding the phrases that were then graded. The number of answers they got correct were then used for their scores.
Don't worry, we didn't forget randomness in our experiment. We randomly assigned half of the subjects to take the visually administered test first using a random number generator and the other half to take the auditory administered test first.
Each quiz had 12 questions, and the subjects were scored on how many they got right out of 12.
The quiz was formatted with 12 phrases such as, Gary wore a plaid flannel shirt to the store, which were either read or spoken to the subject. To test the memory of the phrases, we would then ask 12 questions correlating to the phrases such as, where did Gary wear a plaid flannel shirt?
For the auditory test, we said each phrase aloud only once, and for the visual test, each subject was allowed to read all of the 12 phrases for 1 minute. Then the subjects on both quizzes were read the questions aloud, and they answered on a sheet of paper.
We then took the difference of the 2 scores, comparing the subjects' scores to each other in a matched pairs design.
We then used graphs to analyze the mean differences between both the auditory and visual average scores.
After collecting the data to try and answer our questions about memory, we conducted a paired t-test to finally see if visual learning is more beneficial than auditory learning.
Our variables we are going to be using in our paired t-test are mu sub d, which equals the mean difference of the score of the visual test minus the score of the auditory test, and the variable for that is 1.33.
Our standard deviation is 2.2024 and our n value is 30 with the degrees of freedom of 29.
Our null hypothesis is mu sub d equals 0, and our alternative hypothesis is mu sub d is greater than 0. To satisfy the conditions for inference, we first have random assignment. Our group is also bigger than 30 people, and the 10% condition is also met. After we finished our calculations, we came up with a t-statistic of 2.88 and a p-value of 0.003. With a significance level of 0.05, we reject our null hypothesis. We then decided to perform a one-sample t-confidence interval at 95%. The interval we got was 0.34953 to 2.0376. Because the confidence interval did not include 0 and our significance test resulted in rejecting the null hypothesis, we have enough convincing evidence to prove that for the 30 students tested at Canyon Crest Academy, tests administered verbally earn lower scores than tests administered visually.